Hi dear students, in previous class we completed till enthalpy of different type of reactions and about bond enthalpies. And today we are moving on to our next very important topic, which is the lattice enthalpy. So in this word lattice, it means the arrangement of ions in an ionic crystal. So that's what the lattice means. This you might have learnt earlier. So ionic compounds exist as lattice or in a 3D dimension or 3D arrangement like this. So if we see the 2D structure of that, it will look like this. So this is how ionic crystals are arranged. One ion, then the adjacent next ion, a positive ion, negative, a positive, like that it is arranged. So this is a crystal of NaCl we have taken. So this lattice, when we try to dissociate it with the help of heat, then comes the importance of lattice enthalpy. So when we take 1 mole of this particular lattice and we provide energy to dissociate this lattice into separate ions. So when we provide heat, we break the bond or break the interaction between them and we separate the ions. Then that particular energy is known as lattice enthalpy or lattice energy. So the energy needed to dissociate these ions from 1 mole of lattice is known as lattice enthalpy. So enthalpy change which occurs when 1 mole of an ionic compound dissociates into its ions of gaseous state. So that's our definition. This is an example given here. When NaCl solid, it breaks down to gaseous form and into ions. The energy needed for this is known as the lattice enthalpy, which is positive 788 kilojoules per mole. So it's an endothermic reaction. We are providing heat for this particular process. And finding this amount is not an easy task. So finding it with experimental methods through direct method is not at all possible in chemistry. So we need to go step by step for this procedure. So as enthalpy is a state function, if we find the enthalpy with one step or in different steps, we will get the same result. So as finding it in one step experimentally is difficult, we are finding it in different steps. So for that we have a method in chemistry, or it's a kind of cycle which is known as Born-Haber cycle. So with the help of Born-Haber cycle, we need to find out what is the enthalpy change when the lattice is broken or dissociated into its ions of gaseous state. So for that, we are considering the example of NaCl only, and we will write the reaction into steps. So the first step is sodium solid converted to sodium gaseous. So the solid atom is converted to gaseous atom, and there what is the type of enthalpy? Which is solid directly converted to gaseous, which means it's a enthalpy of sublimation. So enthalpy of sublimation with an endothermic process of 108.4 kilojoules per mole. And next step is this sodium gas or atom of sodium in gaseous state is converted to an ion. So one electron is loosed and that becomes Na plus. Sodium loses its one electron and becomes Na plus ion. So what is it? It is an ionization process. So hence the enthalpy will be ionization enthalpy, which will be an endothermic process of 496 kilojoules per mole. So sodium from sodium solid from the lattice have changed to sodium positive ion, ready for the reaction. Next is the chlorine. So we have taken the amount of chlorine which is properly needed for the particular sodium. So we have taken half Cl2, that becomes half Cl2, which is half mole of Cl2 gas is converted to 1 mole of Cl atom. That is the bond dissociation enthalpy or bond enthalpy of this particular molecule. Here half moles of chlorine breaks down into 1 mole of chlorine atom, and that is the bond enthalpy. As there is just half moles, it is half bond enthalpy will be equal to endothermic process of 121 kilojoules per mole. Next, when the chlorine gaseous atom accepts one electron and becomes Cl minus ion. So Cl minus ion in the gaseous state. It's a electron accepting process. So its an enthalpy is electron gain enthalpy. So electron gain is happening here. So it's an enthalpy which is of electron gain. So the electron gain enthalpy which is of exothermic nature. So when electron is accepted, the energy is being released. In all these cases, energy was accepted. In this case, it's a negative value. So energy is released. So it's an exothermic process of 348.6 kilojoules per mole. And next process is Na plus Cl minus. So Cl minus is ready in the gaseous form and sodium was already ready in this process. So both of them combines to form Na plus Cl minus solid. So that is the process where we have the lattice enthalpy. So finally we are getting the lattice enthalpy here. The sodium and chlorine at its gaseous form combines to form Na plus Cl minus. That is the lattice enthalpy. And we have two types of lattice enthalpy, which is the lattice dissociation enthalpy and lattice formation enthalpy. In both the cases the value will be same. So when we told about this reaction, we told about the lattice dissociation enthalpy where the lattice is broken down into ions. And if we reverse the reaction where we get the lattice formation, Na plus Cl minus gives NaCl. That is the reaction which we have written here. Both the cases we will have the same amount of energy, but just the sign will change. So lattice enthalpy can be found out in both the cases where lattice breaks down into ions and ions combine to form lattice. So in this reaction it is lattice enthalpy, but the sign will be negative as it is a combination or lattice formation reaction. But lattice dissociation means we get a positive value. So to dissociate Na and Cl, we need to supply energy. That's why we have a positive value. And when we combine to form the lattice, then the lattice enthalpy will have a negative value as the combination or formation gives out energy. After combining, it gives out energy. So that will be an exothermic process. Hence, the lattice enthalpy here will be having a negative value with the same amount of energy. But now we are not concerned about this reaction or this value because we need to find it from other steps. So the value is unknown to us right now. So we are not concerned about the value. We will see how to find out from this particular steps. So for that, the same steps we are writing like a cycle now. So first, the sodium solid will change to sodium gas with the sublimation energy of positive 108 as we told. So now next changes, sodium again will convert it to Na plus ion with ionization enthalpy of 496 kilojoules per mole, and then the chlorine comes, chlorine dissociates to Cl gas forming dissociation energy of 122. Then again electron affinity, which the chlorine gains an electron and becomes Cl minus. So now both of them will combine. Both of them are in the gaseous state and that too in ionic state, and they combine to form NaCl. This particular energy required is known as the lattice enthalpy. So this step will gives us the lattice enthalpy, and that energy we need to calculate. We know how much is the value of this and all of this. So we need to find this value. The same chart is given in your textbook in a different way like this. So it is nothing but the same chart. So starts from here, sodium converted to gaseous. The only changes in this case, both the sodium and chlorine is shown together. It is not shown in a separate way. So together it is shown. Na plus half Cl2 gives Na plus half Cl gas. Sodium is converted to gaseous form with this much of energy, and similarly all the changes goes, and this is the lattice enthalpy which we mentioned. So how to find this particular energy? We have two methods here. One is to find out the lattice formation enthalpy, or we can find the lattice dissociation enthalpy. We will have the same value in both the cases, but sign only will change. So first we will see how to find out the lattice formation enthalpy. So for that, how it is done? We know the enthalpy of formation between sodium plus half Cl2 giving NaCl, this particular reaction from here to here. So this reaction will have an energy of 411.2, negative 411.2 kilojoules per mole. So this value is actually the enthalpy of formation, which is the sum of this value plus this value plus this and this one. So all these values together, if we sum, we will get this particular value. And if we don't know this value, we can find it easily from this concept. So this particular value is equal to this plus this plus this plus this one and this one. So when we have the sum of this and when we know this value, we can easily find out the lattice enthalpy here. So how it is done? So this slide we have written all the changes, and now the thing is sum of all this is equal to the enthalpy of formation, which is equal to negative 411.2. So when we know the sum and we know all the other terms, we need to find out just the lattice enthalpy. So what is to be done? To find this value, this particular value minus the sum of these four values will gives us this value, right? So enthalpy of formation minus enthalpy of electron gain minus enthalpy of bond formation minus ionization enthalpy minus sublimation will give us the value of lattice enthalpy. Hence the value will be 411 minus of minus 348 minus 121 minus 496 minus 108.4. Hence we will get the value negative 788, and this is the lattice enthalpy. So we found out the value of lattice enthalpy, and this lattice enthalpy, which is of negative value, is of lattice formation enthalpy. And lattice dissociation, how we calculate, that we will see. So finding the lattice dissociation enthalpy is much easier than this. We just need to see the Born-Haber cycle and we need to sum all the other energies to get the lattice enthalpy. So lattice enthalpy is the sum of all other energies. So we just need to add the enthalpy of formation plus enthalpy of sublimation plus enthalpy of dissociation plus enthalpy of ionization plus enthalpy of electron affinity. As it was a negative value, it is given negative only. So all this when we sum, we get the same value of lattice enthalpy, which is 788 kilojoules per mole. But in this case, we got it as a positive value because it is a lattice dissociation enthalpy. In the previous case, when we got the lattice formation enthalpy, it was the same value but with a negative sign. And now we got with a positive sign. That's the only difference. So this is how we find the lattice enthalpy. You can study any of this method, but particularly in your textbook it is given this particular method of summing all the other energies to get the lattice enthalpy. So you need to concentrate more on this method. So continuing the enthalpy of lattice, in your textbook they have given enthalpy of solution and comparing this with internal energy and all. So that we will study only after we finish the enthalpy of solution. So please wait for it. We will continue that in the next class. So prepare notes from the slides and submit it. Thank you.